is section 5.4. We're going to talk about medians and altitudes of triangles. The median of our triangle goes from the center of one side to the opposite vertex. The center of one side to the opposite vertex. Where all the medians meet up, that is called a centroid. So the medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint. So if we look at the distance from E to C, the distance from C to our point P is 2/3 our entire length. So an orthocenter is the altitude of the triangle. And in case you don't remember what an altitude of a triangle is, it is what we have been using since we were small children in elementary school to calculate the area of a triangle. It is technically considered the height of the triangle. So it's the point that goes from the vertex and is perpendicular to the opposite base. That is the altitude of a triangle. It is perpendicular to the opposite base. So sometimes that is definitely, like for here, this altitude definitely doesn't cut my side in half, but it's what we classically use when we're doing area of a triangle. The cool thing is, we have a triangle, so we're going to have 3 different altitudes. So we find the point that's perpendicular to the vertex, or it goes through the vertex and is perpendicular to the side. Then we rotate our triangle. You guys, when you're doing it on a piece of paper, you just rotate your triangle. You do that same skill. Make a perpendicular line from the vertex to the side. On an acute triangle, the orthocenter is inside the triangle. On a right triangle, the orthocenter is on the edge of the triangle. And in an obtuse triangle, the orthocenter is outside the triangle. So orthocenter doesn't technically mean the center inside the triangle. It could be any of these 3 places. So when we look, the beauty of orthocenter is if we do it on a grid, we know stuff about perpendicular lines on a grid, and we know stuff about distances on a grid. So we're going to plot A, B, and C on this grid. Then we're going to find the orthocenter. It says, the hint says you only need to find and graph the equations of 2 of the lines, because where those 2 lines cross, that 3rd one is also going to cross, and that is a test question, my friend. So you only need, I'm going to write it down because this is super important so that you can answer this correctly on your test. You only need to find where two of the lines cross. Because the third line is also going to cross there. So you only need to find where two of the three lines cross, because your third line is just going to cross right there as well. All right. While you guys are finishing writing that down, I will plot these 3 points. A is 1, 3. B is 2, 7. And C is 6, 3. Since we have our rulers with us, let's go ahead and make straight lines. Between each of our points. Okay, so the easiest altitude to find is going to be the one that goes from B vertically down. So I will put that in red. So if we look, the easiest altitude is this one here. Because I have a horizontal line here, we know that all vertical lines are perpendicular to any horizontal line. It's the nature of horizontal and vertical. So we have zero work that we have to do to find this line here. So what we're going to do to find the line that's perpendicular to BC is we're going to go ahead and find the slope of BC. So the slope, so my perpendicular line is going to be somewhere here. I'm going to find that slope. So the slope of BC is going to be y2 minus y1 over x2 minus x1. So the slope for BC is 3 minus 7, y2 minus y1 over x2 minus x1, 6 minus 2. 3 minus 7 is negative 4, and 6 minus 2 is 4. That is equal to negative 1. Perpendicular slope is the negative reciprocal of negative 1. So the opposite of negative is positive, so our perpendicular slope is going to be positive, and then 1 over 1 is 1. So my slope is going to be 1, and just for fun, we'll put it over 1. So here's the side that I'm finding the slope to. I found the slope of that line. The slope perpendicular is 1 over 1. Which point am I aiming for if I'm perpendicular to this line? Which point does it have to go through? Which vertex? A, B, or C? A. So we're going to start on point A, and we're going to apply this slope. So A is 1 over 1. 1 over 1. 1 over 1. So then I'm going to connect those dots. With a straight line, and you guys have a ruler, so feel free to do that. So the altitude that goes from A to side BC crosses my red line at which point? So it crosses my orthocenter, is at over 2, up 4. Why don't we have to find that third line? Yeah. Because it'll be in the same spot. So we can go ahead and draw it. Because all we need to draw a line is 2 points. So I'm going to go ahead and draw it just to... So it's right here. It's going to go through the same point, so we don't need it. And in fact, we can draw it if we felt like it, but the orthocenter is still going to be at 2, 4.